Here with Solars, Inc. We're an engineering services company out in the Washington, D.C. area. And today I'm going to talk to you can keep your firewall if you want to. It's a way to leverage your existing legacy infrastructure, keep your appliances, but also use open daylight to get improvements in cost and uptime. So what you're going to learn today, there's going to be demonstrations, and I'm going to show both the RESTconf API and the ODL service function chaining feature to solve two real-world use cases that you might face in data center design. There's my email address if you want to contact me. I'm also on the opendaylight.org ask site. My username is runamok, and any questions you have about these slides or the demonstration, I'd be happy to answer. So before we begin, my intention of these slides is to advocate open daylight to the manager types, to the decision makers, any conservative customer who is afraid of the technology. So these are good slides that show an overview, that show a benefit that you could forward to them, and it might be useful. They might take something away from it and say, yes, this is useful for me. So 3 emerging technologies. I hear a lot of talk in the hallways of the government office I support: big data, DevOps, and software-defined networks. There might be some other technologies you guys think are very popular, containers, et cetera. So before I begin, there's a lot of FUD about open daylight and SDN. A lot of people think it's hype. They think that big data and DevOps, they have clear application, but SDN, it appears to be a solution in search of a problem. And a lot of people also think that SDN is just for academia or NFV shops, but it's not relevant for practical use. And again, the last complaint I hear about software-defined networks is that it only applies to greenfield architecture. So these slides are going to prove those attitudes wrong by showing use cases that are relevant and that you could overlay in your existing infrastructure. Before I begin, who here cares about the network? That's a good answer. I show this to developers, and a lot of them are like, yeah, the network, that's great, a bunch of switches in my rack. You need to care about the network because the latency and loss will break your services. And anyone who's watched Netflix, if there's an error with your cable router, you'll see this screen. Another thing I hear from the developers or system integrators are they say, hey, I've got full 10 gigabit per second Ethernet in my core, in my data center. I don't really care about the network because it's, throughput is cheap. But out of the box, if you're not a network guy, layer 2, layer 3, layer 4, their default parameters might work in unexpected or undesirable ways. Spanning tree will block all but one path. Shortest path first at layer 3. It's going to push everything to that first hop, regardless if it's congested. And then, of course, the TCP buffers. Any application developers who took a service off their laptop and put it into the wild knows that latency can be a killer in TCP apps. Another high-level overview. What are network services? We're familiar with load balancing, firewall, DPI. The 2 demos are going to focus on deep packet inspection. I have a customer who has, it's about 20 millisecond hit for DPI, so there's ways of removing it. ACLs, and then if you're in the ISP realm, parental control. But there are other network services. I'm trying to think of a good word here, maybe meta services or housekeeping services. And those are global state, which is achieved traditionally by routing, broadcast domain scoping. We use VLANs to tighten up layer 2. And then on the WAN, you have resource signaling, prioritization and preemption, usually attained through some sort of traffic engineering. Multicast, and then Ncast. It's pretty rare. It's the inverse of multicast. If you have many lossy paths, you could send multiple copies to make sure you get one at the end. It's pretty interesting. 10,000-foot overview of SDN. Again, this was pitched to managers and software dev types, and the best way to summarize SDN to them is that at any given time, you use a centralized controller to move the data through your network as you see fit. Network equipment, open daylight, it includes more than just switches. It includes routers and firewalls, your layer 3 appliances. Open daylight is a platform that allows you to install services from the previous slide as apps. And also, which is really, really important, is it provides a single REST API to configure heterogeneous hardware. That's a no-brainer for software developers, but for people who've lived with the CLI for decades, it's a big deal. A good analogy I like of this open daylight to developers is a sort of an enterprise service bus that abstracts the southbound details from the northbound API. I don't know if that analogy holds one-to-one, but again, it's a good frame of reference. And then service function chains, you provide a service overlay, and the goal there is to fully divorce the services from topology. SDN layers, you have your northbound API, that's your apps, your orchestration, your controller platform that holds the logic, and then your southbound interfaces to your hardware and appliances. Open daylight, Java built, uses Carafe, the OSGI framework, and then bidirectional REST. Again, your network apps hold the logic and algorithms for your network services. And then southbound, there's a whole bunch of interfaces there. This is a good picture from actually I'm going to make this full screen. Good picture from the website that shows your northbound services, your southbound control, and then the controller platform. Service function chaining, as I mentioned before, it enables a service topology. It's an overlay built on top of your existing network. And you can use any technology you want to create service paths. You have your appliance, you have your service. You could get flow to there using VLAN, ECMP, GRE, VXLAN, et cetera. It provides resources for consumption, and the service topology connects those resources. I think the most important thing to me for SFC is that you could quickly and easily add new service functions, and that requires no underlying network changes. I think the killer app there is that you could have network services on demand. So if you're a data distribution system, for example, you could spin up virtual machines of firewalls during peak times, spin them down during the low times. And that kind of network service on demand, I think, will be a huge cost saver in the future. Again, to the software types, software-defined networking, it's incredibly powerful. OpenFlow, for example, you're rewriting the headers. You're changing MAC addresses, you're changing IP addresses, you're changing ports. You need to protect it with as much security as you would a firewall. So those planes, security, identity, and bureaucracy, if you're working for large organizations, those are orthogonal to the technology plane, which I'm going to discuss here. But you really need to pay attention to those if you're going to follow some of my solutions here. And then one more caveat. If you're not a network engineer, if you've never been hands-on writing ACLs using a CLI, the two solutions I show here may spoil you because they're really, really easy and really, really powerful. So I'm going to get to the first demonstration, and first I'm going to frame the issue. It's called DPI, Deep Packet Inspection Bypass. And the first approach is going to look at that REST-conf API. So in this scenario, you want to reduce latency, because if you remember, latency and loss at the network layer will break your services. And you have a data center that performs DPI for inter-network flows, common occurrence. The DPI injects latency in the flow and increases the round-trip time, which is troublesome for TCP. Here's your topology. You have your routers on a stick, your gateways in the firewalls. Traditional deployment to get traffic to the firewalls, to the DPI, you steer them using VLANs and switch virtual interfaces. Then you can use a routing protocol, static routes, to get them through your network. The logic here, to frame the problem, is can we get traffic from client A to client C but only push it through that firewall once. So only one of those DPI, because once it's scanned, you trust the flow. You don't want to waste resources if possible. So you could put the logic in the firewall and say if then bypass, but that's gonna consume resources and may saturate your backplane. Is there a better way? Well, you could put the logic in the switch, and that's what I'm going to demonstrate using Open Daylight. Any questions? Am I moving too fast? All right. Here's a detailed topology, and this is a lot of detail, but in the demonstration, I took this topology and recreated it exactly using a Python script that I fed into Mininet. How many people here have used Mininet? Oh, that's great. For those who haven't, it's, I think the easiest way to describe it is it's a Linux container for network scenarios, modeling and analysis. So let's begin. I'm going to do this live, which is always exciting. And I've already started Carafe. Everyone here is familiar with the Open Daylight, the Carafe interface. So I used that L2 switch command, and then it installed all the dependencies here. One of the cool things from this project is I learned how to use the Google Chrome add-in for SSH, and it's really neat. If you guys haven't used it, I recommend it. All these servers are in the Amazon cloud right now. So we're going to just do Vim. This is my Mininet topology. I set the IP addresses, I set the MAC addresses, and then I use static routes to push through. As you can see, it adds the controller, and it creates a topology, and a quick ping all will show everything reached. If we go to Open Daylight, we'll see that this matches this. So to show that the 2 trip through the 2 DPI, I'm going to do a quick ping. And you can see the round trip time is 40 milliseconds. So in theory, if we cut out one of those DPI detours, we'll cut the latency in half, which is going to be huge for our app. And no surprise, we'll see the path goes through the 2 gateways. So while that's running, bring up that RESTconf API. When I did that ping all, the L2 learning switch created all these flows. We could do this from an OVS OFCTL dump flows, and you could see it here as well. I just want to make sure there's no cached flows. And there isn't, which is good. So I created 2 XML documents that show the open flow logic. So I just call it 202, and you can see here, there's a match that says if the destination is server C and the ether type is 2048, then you do this. And what we do is we hijack the flow. The flow is going to the gateway at layer 2, but instead we change that destination address to the address of the server. And then decrement the TTL as well. So as far as the flow knows, it's going through that gateway. I'm going to bring up my client here. And we're going to put the flows. Okay. So config 202, and we're going to take that flow. Have you guys used Postman? Okay. So I'm a network engineer, and REST APIs and Postman and web services is kind of new for me, so it's interesting that it works. We're going to put it, not delete it. Make sure you put in the config, not the operational store. We get a 202, and that should show up here. And it does. And then we'll do it in the reverse direction really fast. And this is the last time I use Postman in this demo, I promise. So the fact that it's in our operational config means that it successfully went from open daylight to our switch, our operational switch. And that means the open flow logic should be in the switch, which means if we ping now, we'll see it's cut in half. And then an interesting part is when we trace route, don't know why this trace route's so slow. Before the open flow rules, it went to that second DPI gateway, but in this case, it skips it entirely, which is pretty interesting. All right. Let's go to our second demo. Which is an egress bypass. To me, this is pretty interesting. Again, you have your external producer-consumer, and then a DMZ server. This is for a product distribution system where the egress throughput is a lot greater than the ingress throughput. This scenario is near and dear to me. I'm supporting NOAA, the weather satellite, and we have a product distribution system for weather data. So the ingress is a lot smaller than the egress out to the customers. Again, a router on a stick. Do you guys use that term? Or do you use a one-armed router? I've heard both. You steer it at layer 2 to that DPI. Now there's a scenario where the egress traffic is going to increase past the capacity of this flaming wall here. And you realize, being a good engineer, that there are cheaper methods of securing your egress flows than passing them through your appliance, upgrading to a bigger appliance. With egress security, you just want to ensure that the return ACK traffic doesn't include any exploits, and that egress flows do not facilitate any zombies or phone home attacks. Some ideas to ensure that without using a DPI on the egress: ACLs, IP tables, host firewalls, heads on the servers. If you're really paranoid, you could have a unidirectional bulk data push over one-way fiber with EDAC and TLS. There's a million ways to do this. The point is, if you want to do this, I could show you how. The end goal is to DPI inspect the ingress flows, but not the egress flows, since you have other security measures in place. Again, you could put the logic on the DPI appliance, but it might waste capacity, could saturate the backplane, and let's say the egress is 10 gigabits, the ingress is only 1 gigabit, you're going to have to upgrade to that 10 gigabit appliance. Using legacy network protocols, it's very difficult to implement, and it could result in asymmetric routes. That's going to break things, so you don't want to do that. But with Open Daylight, there's a very easy solution that I'm going to demonstrate using 6 flows. All right, so the goal is when external initiates, you put it through the DPI inspection, of course. When the DMZ pushes, that's considered egress, so we want to bypass. However, there might be a scenario where the DMZ does a get, an HTTP or FTP get, in which case that's ingress, so we want to scan that. Here's a detailed diagram. Again, I built this in Mininet, and I put the logic in via that RESTconf API. The logic, if you're interested, is here. You're going to intercept the packets for the put flows, and then for the gets, we're going to use a dummy IP. Still one server on both sides, but I needed a way to trigger OpenFlow. You can only match on layer 4 and below. Obviously, getting put is at the application layer. I'll get into more detail when I demo it. The topology, we'll see this in Mininet. And now it's time for the demo. Just going to set it up. That's the wrong one. So I'm going to open the external server that we're going to push to. I'm also going to open a TCP dump of the firewall. So if traffic's going through there, we'll see packets. And if it's not, we won't. And then I'm just going to open a client for Mininet so I could run the commands. And again, if anybody wants these Mininets, these Python scripts, just let me know. Send me the email. All right, that's fast. If we go to our Open Daylight, we should see the new topology, which we do. And that topology matches this diagram. All right. So now that the topology is in place, I'm going to connect to the server. So that doesn't show anything yet, and then TCP dump as well. Now, the baseline scenario, if our DMZ server does a push to the external server, to the EXT, as expected, the server shows a successful put, and we sort packets through there. Instead of going through the postman, I'm just going to put the flows using a script. And we got some bad requests. I don't know why this happens, but we just have to try for... Have you guys ever seen this using the REST API and curl? Sometimes you just got to push it a few times. And then, of course, 909. And we can verify that they went there going through that RESTconf API. Let's make sure they're all there. Oops. All right, so now that they're in place, I'm going to start up fresh TCP dump. I try the same command again. And in this case, it was put, but it did not go through the firewall. But now let's try the other case where I do a get. And again, I'm going to use that dummy IP. the open flow rules, see this WIP, that triggers the rules to actually scan, and then it changes the IP. You'd have to give it to the remote end, but it's going to see a WIP as well. And in that case, it's the same server initiating, I'm sorry, the same client initiating the same server, but in this case, since it was a GET, that was pushed through the firewall. So is that useful to anybody, or? All right. Secure shell. I'm going to start the controller for my last demo. And unfortunately, it takes a really long time. Whoops. All right, so this is the same approach as the first OpsCon. But in this approach, I'm going to use the service function chaining feature. And a lot of this was based on work that Ericsson did. And it was Brady, Johnson, and Ronaldo. So thanks to them. Early on, I showed those northbound apps, and right there circled, service function chaining. And the idea here is you install the app using Carafe, feature install, ODL, and then SFC. That'll give you the opportunity to use this, this feature. Again, this is really high level. There's a lot of very low level information on service function chaining. But in terms of this demonstration, the steps are you have your firewalls, your appliances, and you register those in your service pool. Those are your service functions. Then you say, I want these switches to agree to be controlled by the controllers for this service function purpose. Those are your service function forwarders, and then you configure the logic. Again, highly abstracted. You register your service function, your network services or appliances, and then you register your service function forwarders, which are the switches. You create service function chains, which is a chain of network services. So a chain might be first firewall, then apply PC, then virus scan. It could be first load balance, then NAT, then ACL, whatever. You define those chains. You create service function paths and rendered service paths, and that is selecting an actual path. So instead of saying, firewall, PC, virus scan, you actually say firewall number 1, parental control number 1. It's pretty self-evident. Again, this is a summary. Most important thing is you create a classifier that will match the flow and apply the appropriate chain. So let's just see if my controller is up and running. And it's running. All right, that's good. That is good. Just going to bring up some putty shells just so you can see things real time. Sorry, mini-net. I'm going to bring up service function forwarder 1 and 2. Those are those switches that I said agreed to be controlled. They're the ones that punt the flows to your appliances. I'm going to run a TCP dump on that just to demonstrate how service function chaining steers the traffic. All right. Have you guys looked at the Deluxe service function chaining UI? I'll bring that up real fast. We're doing on time. All right. Here's the UI. If you remember from that high-level abstraction slide, I mentioned service functions. You could use the GUI to add your appliances, service function forwarders. You could use the GUI again to add your switches. And then, of course, the chains, firewall, DPI, virus scan, and then the actual paths. I have some scripts here. That's just going to use, again, this was written by Ericsson, this particular part, so thanks to them. It's going to push all those flows. And then when we go back, we'll see it's populated with your appliances, DPI 1 and DPI 2, and then your SFF, your function forwarders here. Oops. Okay. Now the last step is to add a classifier, and that's what this script here does. And that just says for any flow, go to service function chain 1. And let me show that to you real fast. So in this demo, I'm going to have 2 rendered service paths. The first one is an ID of 1. It's going to go through service function 2, so appliance 2 first, and then appliance 1. And then I'm going to switch it to 3, and I'll go through 2 only. So got to start the web server. All right, so I'm going to use my client to wget a file from that web server. And since the classifier maps it to that chain with ID 1, it's going to go through 2 first and then 1. There we go. Now we're going to switch it to use rendered service path 3, which you can see here is just going through 2. I'm going to start a fresh TCP dump. And in this case, it only goes through one of those DPI. So this is similar to that first OpsCon in which we're using Open Daylight to bypass that redundant dpacket inspection. In the first case, I used the REST-conf API to push OpenFlow logic. In this case, I installed the service function chain feature into Open Daylight using Carafe, and then use service function chaining, the classifier, and then the rendered service path to bypass. So thank you very much. Those are my demos. And we're about 15 minutes out. Does anybody have any questions? Sir?
Yeah, your DPI, does it have to
understand that? So in this particular case, the service function forwarders, their job is to get the flow to the service, to the appliance. And there's many ways to do it. One of the ways to do it is network service headers. Another way is to create a tunnel using GRE or VXLAN. In this particular method, it's the Ericsson method. They're using actual VLANs. So they're switching VLANs in the switch to detour it. So they match, change the VLAN in the packet, and send it off that way. So to answer your question, no, they're not aware of NSH. Sir? Mm-hmm. Well, this tool lets you, it's very, lets you configure it for your particular use case. And I actually was looking at a bump in the wire, and I controlled it at the switch. But yeah, that's a good question. That's how I would do it. I would try to find what's the last hop before that bump in the wire, and put the logic there. Now, how to do that, I don't know off the top of my head. Yeah. Absolutely. Not to my knowledge. Yeah. Does anyone else have any questions? All right, so again, the slides will be on Wikipedia. And I hope you take away that there's some good benefit that you can use today using Open Daylight, and it's pretty easy to implement once you work out all the bugs. So thank you. If you're not a network guy, layer 2, layer 3, layer 4, their default parameters might work in unexpected or undesirable ways. You know, spanning tree will block all but one path. Shortest path first at layer 3. It's going to push everything to that first hop, regardless if it's congested. And then, of course, the TCP buffers. Any application developers who took a service off their laptop and put it into the wild knows that latency can be a killer in TCP apps. Another high-level overview. What are network services? We're familiar with load balancing, firewall, DPI. The two demos are going to focus on deep packet inspection. I have a customer who has, it's about 20 millisecond hit for DPI, so there's ways of removing it. There's my email address if you want to contact me. I'm also on the opendaylight.org ask site. My username is Runamok, and any questions you have about these slides or the demonstration, I'd be happy to answer. So before we begin, my intention of these slides is to advocate Open Daylight to the manager types, to the decision makers, any conservative customer who's afraid of the technology. So these are good slides that show an overview, that show a benefit that you could forward to them, and it might be useful. They might take something away from it and say, yes, this is useful for me. So 3 emerging technologies. I hear a lot of talk in the hallways of here with Solars, Inc. We're an engineering services company out in the Washington, D.C. area. And today I'm going to talk to, you can keep your firewall if you want to. It's a way to leverage your existing legacy infrastructure, keep your appliances, but also use Open Daylight to get improvements in cost and uptime. So what you're going to learn today, there's going to be demonstrations, and I'm going to show both the RESTconf API and the ODL service function chaining feature to solve 2 real-world use cases that you might face in data center design. I'm going to prove those attitudes wrong by showing use cases that are relevant and that you could overlay in your existing infrastructure. Before I begin, who here cares about the network? That's a good answer. I show this to developers, and a lot of them are like, yeah, the network, that's great, a bunch of switches in my rack. You need to care about the network because the latency and loss will break your services. And anyone who's watched Netflix, if there's an error with your cable router, you'll see this screen. Another thing I hear from the developers or system integrators are they say, hey, I've got full 10 gigabit per second Ethernet in my core, in my data center. I don't really care about the network because it's, throughput is cheap. But out of the box, the government office I support, big data, DevOps, and software-defined networks. There might be some other technologies you guys think are very popular, containers, et cetera. So before I begin, there's a lot of FUD about Open Daylight and SDN. A lot of people think it's hype. They think that big data and DevOps, they have clear application, but SDN, it appears to be a solution in search of a problem. And a lot of people also think that SDN is just for academia or NFV shops, but it's not relevant for practical use. And again, the last complaint I hear about software-defined networks is that it only applies to greenfield architectures. So these slides